A ball of mass m is suspended by a thread of length L. With what minimum velocity has the point of suspension to be shifted in the horizontal direction for the ball to move along the circle about that point? What will be tension of the thread at the moment it will be passing the horizontal position? Solution. In the reference frame of point, ball starts moving with the same velocity as that of point in opposite direction. For ball to move along circle, this velocity must be greater than the velocity which ensures non-zero tension at the highest point of circle. Let the velocity with which the point is shifted is u. So by showing the force, we can write the dynamic equation of mass at angle theta. So let's show the forces acting on the ball at this position. The first force is tension, which is towards the center of circle, and the component of gravitational force mg cos theta away from center and mg sin theta in tangentially downward direction. So we can write the equation of the ball motion in the center direction. T minus mg cos theta equals mv1 square by L. Let's call this as equation 1. The minimum tension at top position will be just equal to 0. Therefore, velocity at top position at minimum tension is v equals root Lg. By putting t equals 0 and theta equals pi, we can get this velocity at top as v equals root Lg. This is the minimum velocity for tension slightly greater than 0. As the mass moves in circle, only gravitational force does work, which is a conservative force. Therefore, mechanical energy of the system during this motion is conserved. So let's obtain the mechanical energy at angle theta. It is mgl 1 minus cos theta plus half mv1 square, and this mechanical energy will be equal to half mu square, the initial mechanical energy. Let's call this as equation 2. Now let's put the value of theta as pi and v1 as root Lg to obtain mechanical energy at topmost point. So we get mechanical energy as mgl 1 minus 1 plus mgl by 2. Since mechanical energy is conserved, this mechanical energy will also be equal to half mu square. From this equation, we can obtain the initial velocity u as u equals square root 5 gl. The horizontal position corresponds to theta equals pi by 2 and 3 pi by 2. At this position, we can obtain the velocity using equation 2 as v1 equals root 3 gl at theta equals pi by 2 and v1 equals root 3 gl at theta equals 3 pi by 2. Now we can put these values of velocity in equation 1 to obtain tension at the horizontal positions at theta equals pi by 2 and 3 pi by 2. So we put the value of velocity v equals root 3 gl and we get t equals mg cos theta plus mv1 square by L, which equals mg times 0 plus 3 mgl by L, which equals 3 mg. Thank you for watching this video.